7.5 properties of logs. I told you today is actually quite an easy day. It really is. Y'all know kind of the exponent rules in general. And today we're going to talk about just basic properties of logarithms. Okay? So here we go. First things first, your product property. If I have a logarithm that looks like this, some log with two things in the argument that are multiplying each other. Well, I can break that into two logs. I can do log of m plus log of n. I can write that as two logs that are being added to each other. Okay? The quotient property. If I have log of a fraction, let's say m over n. Again, I can write that as two logs. The one on top is a positive, so log of m is positive. And the one on bottom is negative, so negative log n. Cool? Basically, the one on top is a positive log, the one on bottom is a negative log. All right? The third property is your exponent property. Basically, if I have something, let's say log of m to the power of n, I can take this exponent and shove it out front. So we can go n log m, like that. I can take that exponent and I can put it in the front. Now, there are, come on ladies. There are reasons to do both. Sometimes you want it expanded because it's easier. Sometimes you want it condensed, it's easy. It's easier. So there are reasons for both. But those are your basic rules. All right, if I were to boil it down to something even easier to think about, here's what I would write.
Do I take my stuff?
I would write, so just go. If it's positive, it's on top. If it's negative, it's on bottom. If it's an exponent, it goes out front. All right, and those are the three rules just kind of bottled down to each other. You got this m over n. The m is on top, so it's a positive log. The n is on bottom, it's a negative log. All right. If it's an exponent, well, we just shoved it out front. Cool. The same with this one up here. This mn, this very top one. Are these two? Are they in the numerator or are they in the denominator? Are they in the top or bottom? They're both divided by what? 1. So they are in the numerator, right? That's why they're both positive. Okay? It really is the exact same rule, just written a little bit differently. Okay? Any questions about this so far? No. All right, here we go. So, problem 1. They say they want us to use these two identities to evaluate the logarithm. Okay? So here's what we're going to do. We're going to expand them and replace them with what we know. So, for example, log base 2 of 3 over 7. Well, the 3, is it positive or is it going to be negative?
Positive.
Why? Because it's on top. So let's write that as log base 2 of 3. What about the 7? Is that going to be positive or is that going to be negative?
Negative.
Why? Because it's on the bottom. Exactly. Log base 2 of 7. And I'll pause. Any questions about that so far?
No, that's it.
Cool. Now, they told us that log base 2 of 3 is 1.585, so I'm just going to sub that out with a 1.585. And they told us that log base 2 of 7 is 2.807, so minus 2.807. And that really is what those logs equal. So pull out a calculator, subtract them. What is 1.585 minus 2.807? What's that? Negative 1 point what?
Negative 1.22.
2. I think it's 3 2s in a row, isn't it? Cool. So we evaluated this log. We didn't know what this equaled, but we broke it into two things that we did know it equaled. All right? And we can solve from there. Cool? Come on, you two. All right, letter B. Did they tell us what log base 2 of 21 is? No, but 21 is what times what? 3 times 7. They told us those two. Let me zoom in a little bit. So that's log base 2 of 3 times 7. And it really doesn't matter which one you put first. And I can break that into two. Are they going to both be positive, or are they both going to be negative? Positive. So I can do log base 2 of 3 plus log base 2 of 7. Cool. Yeah, now I can replace them with what they equal. So the log base 2 of 3 equals what? 1.585. And the log base 2 of 7 equals 2 point what? 807. And those add up to what? 4.392? Yeah, 92. Cool. How are we doing this so far? Give me 5 1. 5, I got this form. Okay, 3 and 2 and lost 1 7. I told you today was not difficult.
So what? You don't multiply it?
By breaking it into 2, it means the same thing. The way we are breaking it into 2 is the same thing as if we left it together and multiply those numbers together. All right, it's just a different way of writing the same thing. So, letter C. We don't know what log base 2 of 49 is, but I can break that 49 into what? 7 times 7. So, log base 2 of 7 times 7, which, write out your next line for me real quick. Write out your next line right fast. Yes, they would both be positive. Log base 2 of 7, because they're both in the numerator. Log base 2 of 7. And in this case, they both equal what? 2.807. 2.807 plus 2.807, which is what? 5.614? Cool. Yes, ma'am.
Have an extra packet?
Extra packet?
Yes.
I don't think I do so far. All right. Do letter D real fast.
Can we just multiply by 2?
Do letter D real fast. You could have multiplied them by 2. You're absolutely right. I might be out of time.
Bro, dude, oh my god, that was my code name. That should be.
Oh, they're right there. Got one more here. I'll hide it here because somebody will just steal it. Probably not the right reason. Sorry. What's up? Sure. All right, so here we go. So, log base 6 of 5 minus log base 6 of 8. Did everybody at least get that far?
Yeah.
Good.
Cool. So from here it's 0.898 minus 1.161, which gave you negative. Because you're talking about why is this minus here?
Yeah.
Yeah, because the 8 was in the denominator. So we subtract that side. Cool. So if you didn't get to the negative 0.263, I'm actually okay with that at the moment. Really what I'm looking for is, did you get this far? If you got that far, we're golden so far. We'll work on the rest later. Cool? All right, as soon as you're done writing, turn to the next page. We're not going to finish this. I don't think you need to. All right, expanding and condensing, or contracting, however you want to say. Like I said, sometimes it's easier to deal with one log with a very complex argument. Sometimes it's easier to deal with a bunch of logs with really simple arguments. All right, it's just what it is. So again, your basic rules are: if it's positive, it's on top. If it's negative, it's on bottom. Exponents out front. Exponents. NENTS out front. Those are the rules in layman's terms. So I'm going to break this into 3 different logs really quickly. So here we go. The 5. That's on top. So is it positive or negative?
Positive.
Positive. So we're going to go ln of 5. The x. Should it be positive or negative? Positive. But I'm going to go positive 7. ln of x. Why did I put a 7 out front? Because that was the exponent. The exponent was right here, and I moved it out front. Cool? The y, would it be positive or negative? Why? Because it's on bottom, not log ln of y. Cool. Just expanded it all the way out in one shot. Letter B, same idea. Now, one thing I will say, you notice how I did not change my base at all, those stayed the same? They have to stay the same. You cannot condense things at different base. You cannot expand things into different base. It has to be consistent, or it does not work. All right, letter B. Let's start with the top. First things first, let me ask you this. How many logs do you think we're going to break this into? Anyone want to guess? 2, 3, 4, 1, what?
3.
3. One for the 3, one for the what? And then another for the y. Good. So we've got log base 2 of 3. Should that one be positive or negative?
Positive.
Positive because it's on top. The x, are we going to add it or subtract it?
Subtract.
But what are we going to put out front? The 5. Very good. 5 log base 2 of x. We cannot change our log base 2. The y, is it positive or negative? Negative. Log base 2 of y. Cool. How are we doing? Give me 5 and 1. 5, I got this. 4, I'm okay. 3 and 2, I'm lost. 1 saved.
10.
I can live with the 10. All right, do the next 2 problems. We got time. Just knock out the next 2 real fast. Let's do this. So the first one should be log base 6 of 3 plus 4 log base 6 of x. Cool? Any questions about the first one? Comments, complaints, limericks? Sweet, the next one. We're actually going to break the next one into 3 logs. Natural logs, mind you. So we're going to go ln of 5 minus ln of 12 minus ln of x. We cool?
Yes.
All right. The most commonly missed one so far today has been the 12. Either they put the 12 in front or they make it positive instead of negative. Something silly, but we figured it out. Any questions about this at all?
No.
Sweet. Like I said, sometimes it's easier to expand it and deal with those. Sometimes it's easier to condense it and deal with that. So problem 3. We're going to condense these. They're all log base 2. Remember, they have to be consistent or you can't deal with it. Like if this was a log base 3, I couldn't do it. So here we go. Log base 2. The 9. Would that go in the numerator or the denominator?
The numerator.
Why?
Because it's positive.
Oh, because it's positive. Okay. What about the 2? This 2 right here. Top or bottom? Top. But it's not just going to be a 2. It's going to be a 2 to the third. Good. This 3 right here. Top or bottom? Bottom. Well, now we're going to clean that up. But are you cool with where we put everything?
Yes.
Why you put a negative between 9 and 2?
That's a times sign. That's a dot. That's not a negative. That's a dot. An ugly dot, but it's a dot. All right. Let's just do this. What's 9 divided by 3? 3. So I'm just going to clean it up. Log base 2 of, that's 3 times 2 cubed. 2 cubed is what? 8 times 3 is? Like I said, sometimes it's easier to deal with 1. Sometimes it's easier to deal with a bunch of them. Just what it is. Letter B, same idea.
What happened with the 9?
With the 9, I divided 9 by 3 and got 3. And then 2 cubed, so 3 times 2 cubed is 24. Honestly, you could have just shoved the whole thing in your calculator and just gone 9 times 2 to the third divided by 3, and you would have gotten 24. That's just however you want to think about it. All right, letter B. Let's scoot over. All right, they're all the same. First things first, what is the base right there?
10.
10. Good. If it doesn't say it, it's either a 10 or an E. In this case, it's a 10. So, log, the X, top or bottom? Top. The Z, top or bottom? Top. Does it get an exponent?
Yes, it's
Gets the 3. Good. This exponent goes right here. What about the Y, top or bottom? The Y. Bottom. It is negative. What is its exponent?
1/2.
Good. What is another way of writing Y to the 1/2? You're close. Square root of Y. So log, you could also write out this. X z to the third divided by the square root of y. That is also acceptable. Okay. Now, here's where this gets you into trouble. Okay. Going from this, if you just stop right here, that's okay. I don't mind. But if we give you this guy right here and say expand it out, this needs to turn into that. You follow me? You need to recognize that the square root is an exponent of 1/2 and move the 1/2 out front. Does that make sense?
Yeah.
We cool with that? So just it's an exponent rule we've been dealing with for months. Don't forget it. That's how some of these things get tricky as we start piling things on top of each other. All right, do C and D. Take, I don't know, 45 seconds, do C and D. So the first one, you should just have written log of x over 9. Cool? Like I said, 8 seconds. The second one, so if we clean that up a little bit, we're going to have ln of 4 times 3 cubed divided by 12. We're cool with that? All right, now simplifying this, you can shove it in your calculator that way. I'm actually going to prime factor it a little bit. That's ln of 4 times 3 times 3 times 3. 12 is 4 times 3, right?
Yeah.
So I can just go ln of 9. You follow me? You do not have to do it that way. That is not even a way we typically teach you to do it. But that's how I think through it, personally. That's like my mental math steps. But it's however you want to think through it.
Oh.
You right?
Yeah.
Actually, not.
It's not.
6.
Whatever. All right, turn the page. The next page is even harder. Oh my goodness. No, it's easy as pie. We've actually taught you how to do the next page already. We just haven't formally discussed it. All right? It's the change of base formula. So let's say you get a base. We'll call it base C that you don't like. It's base, C in this case, let's say it's 1.327. Yeah, that's an ugly base. We don't know. We don't want to deal with that. So let's say you have log base C of A, and we need to put that in our calculator. Well, I can change that to a base I like. Like 10. But do you remember which one goes on top? The C or the A? Which one goes on top? Do you remember? The A. This is how we put it in the calculator. The log of your A divided by the log of your C, of your base. Okay. It is called your change of base formula, which we have discussed before. That's how you calculate these in your calculator. So here we go. Problem A. They say to use common logs, which that's just the log base 10. So here we go. Which one are we putting on top? The 8 or the 3?
8.
And on the bottom goes the 3. Just take it in your calculator. Give me an answer. Log base 8 divided by log base 3. Don't forget to close your parentheses. A horse is a horse. What? What'd you say, Willis? One point. 1.893.
Not bad.
Cool. I'm not going to go across. Just to the bottom one. Okay, in this case, again, what number goes on top?
8.
8. So we're going to go log of 8 divided by log of 5. Show that in your calculator. What do you get? 1.292. Does that make sense? Like I said, we've done this before. Just so we're all on the same page, no one's doing anything, so do letter D real fast. Just do letter D. We want to make sure we're not doing anything, any like silly mistakes.
Beat him up. Beat him up. I know.
Oh, I got it. 1.269.
Here we go. You're right.
Shut up.
Log 14 over log 8. 1.269.
I got it. 8.
Let me zoom in a little bit, clean this up. Cool. All right, the part just underneath this. All right, they say don't use your common logs. They say use natural logs. Well, would you like to look at your calculator and take a guess as to what button the natural log is? The ln button. That's your log base e. Your ln is your natural log. You can do the same thing with natural log. So I'm just going to go ln of what on top?
24.
Divided by ln of 6. Exact same process. You'll get the exact same answer. So what's ln of 24 divided by ln of 6?
5.694.
5.694. That sounds right. Cool. So here's the deal. Is that not right? Did I do it?
1.7.
Log of 24 divided by log of 6.
Terry.
Oh, I hit the wrong button. 1.774. You're right. Thank you. 1.774. Did you not close your parentheses?
No, I didn't do that.
Yeah, that's what happened. And you gotta close them. All right, so here's the deal. Shh. Here's the point they're trying to make. Ladies and gentlemen, shh. Here's the point. If you're changing your base, it doesn't matter which one you use. You can use your common log base 10 or your naturals, log base E. It doesn't matter as long as you're consistent. All right? Use both naturals or both commons. You can't mix them. Does that make sense?
But it won't change the answer.
It's not going to change your answer. Yeah. If you did log of 24 divided by log of 6, you will still get 1.774. It does not matter. Okay? You will get the same answer. All right. So here you go. Let me ask you this. How hard is this?
Not at all.
No. It really isn't, right? So
Things are some things are not.
here, there are a few things that might be tricky, but it's not hard. You can pick up on it real fast. So here's the problem. Shh. Here's the problem. Most people hate logs because they learn their rules, sort of, and when we start applying those to actually solving, which solving is not difficult, the rules are not difficult, but when we merge those skills together and you're trying to think through both at the same time, that's when things start getting hairy. You follow me? It's not hard, but it's kind of like, you ever seen a kindergartner try to read?
Yeah.
They barely know their letters, and you're asking them to read. They can do it, but it's difficult. All right, that's what it's like. If you want to solve without knowing your rules, it's like a kindergartner trying to read. All right? So over the next few days, you need to work through these. Do your homework, get them down. So that on Friday, we'll be good to go. Does that make sense? All right, that really is what it requires. All right, last question, and we'll be done. Scroll down. The word problems. Okay, the word problems basically are this. There's no way to, hey, you have to build a log out of this. Well, there is, but not really. So they're basically going to give you a function with a log in it and ask you to manipulate it. So we have, stop. For a sound with intensity I, so you have a certain intensity of sound, is given by this function, this, the loudness, where I is a constant, blah, 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 blah. Anyways, an artist in a recording studio turns up the volume of a track so that the intensity doubles. Okay, so its I is going to double. What is the difference in the loudness? AKA the decibels. All right? It doesn't double. It's log-based, so it doesn't double. Okay? And they want an exact answer, which basically means leave it as a log. Don't give a decimal because you're rounding. They want an exact answer. So here we go. To find the difference, we're going to take L of twice the intensity and subtract the original intensity. Okay? We're going to take twice the intensity and subtract the original intensity. Just plug that into the equations and simplify. Okay? So, let's take that equation right here. Where is it? and plug in those numbers for I. So that's 10 log. And on top, we're going to put a 2i for the first one, divided by I sub o. Because I sub o is a constant. Okay. Minus L of I. So that's minus the second one. We're just going to plug an I in for it. So that's
What is letter 0 in the I means?
I of I sub o. I is the intensity of a barely audible sound. All right, that's what they give. So it's a constant in this case. Okay. So these are your two functions. We basically took the first one, plugged in a 2i. Took the second one, plugged in an I. Cool. And then we're going to simplify. So I'll start off. I'm going to break off that 10 and just deal with the logs. Cool. Just get rid of the 10. Move it out. I just divided it off and stuck it out front. Now, question. What is the difference between these two logs? What is the only difference? The 2. One has the 2 in it, one does not. So I'm going to expand this log so that the 2 is broken off. Okay? The 2 is on top. So would it be a positive log or a negative log?
Positive.
Positive. So I've got 10 log of 2. And then I've got log of I over I sub o. I broke that off. I broke this one into two pieces, the 2 and what the 2 is multiplying. Cool. And then I just drag the rest down. Minus log of I over I of o. All right. Now, does anybody notice anything nifty about this? Other than the fact that it's really long. It's actually really not that long.
I mean, compared to other ones,
You can count them out.
I can cancel them out. You notice how this term and this term are identical,
Yeah.
except one is negative? It's kind of like a +2 and a -2. They add up to 0. So the i's essentially go away. So your answer is 10 log 2. That's your answer. Cool? Huh? The whole thing boils down to a 10 log 2. Straight up. The whole thing boils down to a 10 log 2. And that's it.
You take out the